Hi everyone. I hope you're doing great and thank you all for giving your time to me in order to share my findings about microgrid. I'm Farid Varaste and I'm going to present my studies about the topic I've chosen. The title of this research is a Techno-Economic Analysis of Using Distributed Energy Resources and Hydrogen Energy Storage System in a microgrid which is connected to the utility grid. The purpose of this study is to find the optimal configuration of a microgrid components, including distributed energy resources like small wind turbine, photovoltaic system, and also hydrogen energy storage equipment, including alkaline electrolyzer, hydrogen tank, and fuser system. In this article, modeling for microgrid with a specific demand for electrical and thermal load has been done. In addition, mixed integer nonlinear programming optimization and sensitivity analysis have been performed in two different scenarios. In the first stage, I'm going to explain some technical vocabulary and concept which might be unfamiliar to you. The first one is techno-economic analysis. Techno-economic analysis is a method of analyzing the economic performance of an industrial process or product or services. It typically uses modeling to estimate capital costs, operating costs, and revenue based on technical and financial parameter. A microgrid is a set of energy resources that can operate independently from the electricity grid, if needed. I mean, a traditional microgrid relied on fossil fuels, but now low carbon microgrid run predominantly on renewable energy. A microgrid has many of components of regular grid, but on a smaller case, a microgrid can connect and disconnect from the grid to enable it to operate in both grid connected and island mode. In utility grid system, the majority of power outage are caused by damage to transmission and distribution line, but microgrid provide electricity closer to the point at which it is consumed. So there are fewer point of weakness and failure in this scenario, and this lead to a more reliable source of electricity. For several decades, conventional power generation was transformed to the load center over long distance. So there was a huge cost involved for the infrastructure development of longer transmission line. The longer line have issue with stability and voltage profile management for their reliable and flexible operation. Distributed energy resources lead to a reduction in infrastructure costs and reduce the network loss. Power to hydrogen is the process of using electrolysis to split water into hydrogen and oxygen using electricity. Hydrogen is a versatile, clean, and safe energy carrier that can be used as a fossil as a that can be used as a fuel for power, or as a feedstock in the industry. Power to hydrogen is a new paradigm for power generation and energy storage. This system can provide some valuable service like peak shaving and backup power because it releases high output power in short duration and act as a clean power storage in microgrid. In the energy industry, peak shaving refer to leveling out the peaks in electricity use, by consumer. I mean, power consumption peaks are important in terms of grid stability. In addition, they also affect the power procurement cost. In many countries, electricity prices for large scale consumer are set with the reference to the maximum peak load. So the reason is that the amount of power production needs to be designed to accommodate this peak load. The microgrid in a small network of electricity use with local source of supply that is usually attached to a centralized utility grid, but is able to function independently. This microgrid can be used the CHP, small wind turbine, solar photovoltaic systems, hydrogen energy storage system, including electrolyzer, hydrogen tank and fuel cell, and also absorption chiller, compression chiller, cooling storage system to meet the heating, cooling, and electrical demand. Optimization modeling is a form of mathematics that attempt to determine the optimal maximum and or minimum value of a complex equation, and makes integer non-linear programming is the area of optimization that address non-linear program with continuous and integer variables. As you may know, every optimization problem has three main components: objective function, variables, and constraint. In this article, the objective function can be divided into five groups: investment plus aggregated operation cost, uh, interruption cost, and the cost of electricity purchased from utility, the income from selling power to the utility grid, and also the income from the DRP program. And the optimization of this model has been done in Lingo and also MATLAB software. And now we are discussing about a demand response program because it plays an important role in optimization model. Demand response program is a technique which change the power consumption of consumer to better match the demand with the supply. Demand response program seek to adjust the demand for power instead of adjusting the supply. which is typically in the dispatch of the conventional utility grid. The DRP, consists of several parts, and some of which would be time of use and direct load control. Under time of use program, our bill will be determined by how much energy we use and what time we use it. This price uh, and peak times vary based on the season and the days of the week. The consumer may adjust power demand by postponing some task that requires large amount of electric power, and some customer may switch part of their consumption to alternate sources, such as solar panel or batteries. Uh, DLC, I mean direct load control, is a program in which consumer receives some payment from the utility for allowing the utility grid to control the operation of some equipment during peak hours of the day, and also peak hours in the season. In order to demonstrate the pros of using distributed energy resources and GRP program, the result of optimal configuration of microgrid is compared in two different scenarios. In the first scenario, microgrid should meet the demand load by purchasing the whole demanded power from the utility and using gas-fired boiler and compression chiller to meet the heating load and also, the cooling load, I mean. But in the second scenario, microgrid can use CHP, wind turbine, photovoltaic system, and a storage system, uh, and also using the the scenarios, the program of selling the surplus power to utility, and also contribute in terms of in times of use, I mean, and DLC procedures. After performing optimization, the result of two scenarios are as follows in the tables. The optimal configuration of a microgrid in a fair scenario is two boiler whose capacity is 3000 kilowatts, and two compression chiller whose capacity is 3000 kilowatts, which is equal to 850 tons of refrigeration. However, the optimal configuration of grid for the second scenario include three CHPs, one boiler, two absorption chillers, one compression chillers, and 400 kilowatt photovoltaic systems, and eight small wind turbine and five hydrogen energy system with capacity of 100. Simulation in the use of a physical parameter help to determine decision and make prediction about the system. In the left program, the hourly profile of heating and cooling and electrical demand are specified on an hourly basis, and optimization performed based on these input parameter. And as can be seen from the right diagram, in some period of time, using the photovoltaic systems in order to sell the surplus power to utility grid is financially viable, even by considering the operation and the maintenance cost of this equipment. Uh, in the last slide, we are discussing the sensitivity analysis. The sensitivity analysis is a tool, used in financial modeling to analyze how the different value of independent variables affect a specific dependent variable under certain condition. And as can be seen from the table, and yeah, these are views that the growth of interruption cost uh, leads to the use of, you know, hydrogen energy storage and a wind turbine. Thank you for your attention.